Hi guys, welcome to your Unit 2 review. So today we're going to be covering inequalities. So I'm going to do this review a little different than I did last semester, okay? Last semester it was very structured and based on the test. For this, I'm going to really focus on just the major concepts, okay? And then also, I will go through some examples, but they're not going to align perfectly with each question, okay? So I'm giving you a little bit more control. I'm giving you a little bit more opportunity to be like, I know this stuff, right? It's not just what Miss Angel knows. So keep that in mind as we go through this. I think it will still be very helpful, and we're going to go over plenty, but just be aware of that. Okay? So, yeah. So an inequality is an expression that has more than one answer, right? So x is greater than 2. That means any number that is greater than 2 could be an answer for that inequality, right? Which is very different than like x equals 2. So that's what we really need to consider. I made this little chart. If I were you, you might want to screenshot this or pause the video and write it down. So I wrote down the symbol. So this symbol is called a less than symbol. This is less than or equal to, greater than, or greater than or equal to. In words, now these are just like one example of what you might see in like a word problem that mean like the different types of inequalities. There could be others, but so words that mean less than or less than, fewer or fewer than, less than or equal to would be no more than, greater than would be more than, and then greater than or equal to could be like at least. Okay? I also added the graph. And so what this means is that like it should have an open circle because whatever number that is on is not included in the number set. And then the arrow should be pointing to the left, right? Just like the symbol, this looks like the end of an arrow, right? This one would have a colored in circle, or sometimes I call it a closed in circle. So if you ever hear me say that, that's what I'm referring to. And again, the arrow pointing towards the left. Greater than should have an open circle with an arrow pointing to the right. Greater than or equal to should have a colored in circle with an arrow pointing to the right. Just some quick notes before we get into some examples. To solve inequalities, treat them just like equations, right? So we've been working with this for a couple weeks now. And so, yeah, you solve just like you would with equations. Something important and something that's new, and it's actually not covered in your lessons, which I don't know why they excluded this, but I felt like it was really important for you to still learn, is what to do if you multiply or divide by a negative when you're solving. And you must, in that event, you must flip the inequality symbol. We talked about this in live lesson, not only this week, but also on the 15th, okay? So yeah, if you want to go back and look at those lessons, you can. Otherwise, we're going to do some examples right now that some of them will involve negatives, and I'll talk through that as we go. So let's get into some examples that should help you be successful on your test. Okay? So, we're going to go through quite a few. Let's see, I got 9 set up for us. So let's see here. Number 1, x plus 5 is less than 7. All right, so again, I'm going to treat this just like I would an equation. So right now I am adding 7. Oh, no, just kidding. I'm adding 5. So to get rid of that, or to isolate my variable, because that's always my goal, right? I'm going to subtract 5 from both sides. 5 minus 5 is 0, so those cancel, and we're left with x is less than, and then 7 minus 5 is 2. Now, for each of these problems, I am going to go ahead and graph them as well, so that way you have plenty of examples of graphing. and how to read them and create them. So with this one, let's see here. I'm going to make a number line. I'm just going to make mine pretty little today. I usually, whatever this number is, I usually put that right in the middle of my number line, and then I'll add a few numbers around it. Okay? I'm going to use another color. Let's see. I will use blue. Red and blue. So, for the graph, I'm going to circle whatever number is right there on the right-hand side of the number line. So I'm going to circle, or I guess I didn't circle the actual 2, but I circled the location, right? And then this trick that I'm about to use works when the variable is on the left. So if you ever find yourself in a situation where the variable is on the right, you can flip the entire thing, which would include the symbol, to get the variable over on the left, and it would still be true. So, but anyway, in this case, it's already on the left. My inequality symbol, my less than symbol, looks like the end of this side of the number line. So that's the direction that my arrow should point, okay? I'll go like that, all right? And so that what that tells me is that I could put any number in there that's less than 2. This arrow signifies it keeps going, but I don't have the time, the energy, or the paper to make it go on forever and ever and ever, right? So that would be the final answer. X is less than 2, and then an open circle on 2, because 2 is not included, because I can't put the number 2 in here, right? 2 is not less than 2, so that wouldn't work. So that's why it's not colored in, all right? But that's where the graph starts. Anyway, moving on. Hopefully that makes sense. If it doesn't, reach out to me. With number 2, we have 3x is greater than or equal to 9. So right now I am multiplying by 3 in the problem. To cancel it out, I'm going to divide both sides by 3. 3 divided by 3 is 1, so those cancel. I'm left with 1x, or I just have x on the left. Then I have a greater than or equal to symbol, and 9 divided by 3 is 3. Okay, so that's my inequality. And then once again, we can build our graph. I'm going to put 3 in the middle. You can make them bigger than this if you want, or obviously the ones on the computer are already going to be generated for you, right? Then I'm going to circle the 3. This time, x is greater than or equal to 3, which means I need to color in the circle because 3 is part of my answer set. Okay, 3 is part of my answer set because I could put 3 in here. 3 is greater than or equal to 3. This time, my symbol, it's a greater than symbol. It looks like this end of the number line, so that's the direction that my arrow should face. Okay, and you could plug in a number to make sure that it makes sense. 4 is greater than 3, so that works. Okay, this next one is a two-step problem. Remember, with two-step problems, first we get rid of addition or subtraction because we're working backwards through the order of operations. So right now I am subtracting 3 in order to cancel that out. I'm going to add 3 to both sides. That means I'm left with 2x is less than or equal to 14. Now I am multiplying by 2. In order to get rid of that, I'm going to divide by 2 on both sides. We got to keep it balanced. Okay, those will cancel on the left. I have my variable is less than, and then 14 divided by 2 is 7. Okay, on our graph, put 7 in the middle. Okay, I'm going to circle the 7, that's where my graph starts. I do have a less than or equal to symbol, so I'm going to color in my circle. And it's a less than, so that means it needs to match the left side of the graph with the arrow pointing to the left. For number 4, here's our first negative number that we're multiplying or dividing by, right? So to solve, I need to divide both sides by -2, okay? And this is where and you're just going to have to find a way to remember it, like a little alarm goes off in your head that when you divide or multiply by a negative in an inequality, you have to flip the symbol because it makes everything opposite. So -2 divided by -2 is 1. So then I have x is less than -6. Now, and you can test it, be like, okay, did I do it right? Well, let's see. If we choose a number that's less than -6, maybe I choose -7, and I plug -7 back into the original inequality, -2 times -7 is +14, which is greater than or equal to 12. Okay, so it worked by flipping our symbol like that. And then we would, at that point, we just graph it just like we have been. It doesn't change our graph at all. We have to graph it from this point. So we've got -6, -5, -4, -7, -8. And then we will go ahead and we will circle our -6. Okay. Now, this is a good one to test too. We could, let's say, first off, we have just less than, so we don't want to color in our circle. But let's test it. What happens if we do put in -6 to the original problem? -2 times -6 is +12. Is +12 greater than 12? No. So it doesn't work. That's why we're not going to color it in. And our symbol looks like this end of the number line, so that's the direction that our arrow is going to face. Okay? So hopefully that makes sense. Okay, number 5. X divided by 4, or x fourths, is less than 2. Well, right now I'm dividing by 4, so in order to cancel that out in my problem, I need to multiply both sides by 4. Because when you multiply and divide by the same number, they cancel each other out, and we're left with our variable, which is x, is less than, and then 2 times 4 is 8. At that point, we can go ahead and graph. So let's see, we've got 8 in the middle, 9, 10. Okay. I'm going to circle the number 8. Not going to color it in, right? This looks like the left-hand side of the number line, so that's the direction my arrow is going to face. And again, if you're hesitant on it at all, go ahead and test it, right? Test your answer, okay, and see, does it work? Number 6, a two-step problem. Well, first I'm going to get rid of my addition or subtraction. So right now I'm subtracting 12. So to get rid of it, I'm going to add 12 to both sides. That leaves me with -3x is less than 18. Okay, let me see. For some reason my camera seems to keep getting kind of blurry. Hopefully that's a little better. Okay, with this next step, now I'm multiplying by -3. Well, to get rid of it, that means I need to divide by -3. Well, when I'm dividing by a negative, that's a big deal. X needs to be greater than, remember we got to flip that symbol, and then 18 divided by -3 is -6. Okay, so with this one, we graph from this point after we've solved, but we just got to make sure that we flip that symbol. So I'm going to put -6 in the middle of my graph. I almost went backwards. That's what I'm going to circle. It's just a greater than symbol, so I'm not going to color in my circle, but it looks like this side of the number line, so that's the way my arrow is going to face. Okay, so there's 6 solid examples of exactly what you need to be doing and understanding in order to be successful, not only on your practice, which actually counts as a quick check this time around. So in the past, those practices, they, Miss Salstein and I dropped the original practice and we entered in a quick check. So this one counts towards your grade, so just be aware of that. Don't just fool around on the practice, okay? Do your best. All right, number 7 is a word problem. A truck can carry a maximum of 1,800 pounds. The driver weighs 150 pounds and each box weighs 30 pounds. What is the greatest number of boxes the truck can carry? Sorry, my handwriting is a little messy on that one. I'm sorry. Hopefully you can read it. Okay, so we know the max. So it's okay if it hits it, okay? But the max is 1,800. Okay, so I'm going to put a less than or equal to symbol of 1,800 or 1,800 because all of this stuff over here, the problem that we're about to set up, has to be less than or equal to 1,800. Like this is the absolute most that it can be. It's okay if it hits it, but it can't go over. So let's see, we know the driver weighs 150 pounds, okay? So that's just a constant, right? That's his weight. And then boxes weigh 30 pounds. So we could say, we could define our variable B for boxes, right? And they're 30 pounds each. Most of the time in math, that means to multiply. So 30 times B for boxes, so 30 pounds per box, plus another 150 pounds. This all has to be less than or equal to 1,800. And I'll give you a hint, this problem actually is modeled off of one from your test. So just be aware of that. So hopefully this helps. Okay, after that, we can solve. So for now, I'm going to, let's see, right now I'm adding 150. Well, let's take away that 150 from the total weight especially, right? Because that's going to tell us how much weight we have left for the boxes to add up to. So these will cancel, then we're left with 30B is less than or equal to 1,650. Okay. So we can divide that into groups of 30. That way we know each box, right? Because each box is 30 pounds. So each box needs to be less than or equal to, and then let's see here, 1,650 divided by 30. 55. Okay. So this is the number of boxes has to be less than or equal to 55. So the final question is, what is the greatest number of boxes the truck can carry? 55. That would be your final answer. Okay? Right? It can't go over that. If it goes over that, then the truck could be damaged or might not even be able to run. Okay, so hopefully that helps. And again, that's modeled off of one of the problems on your test. All right, number 8, I wanted to include one that involves a fraction. Remember, when you're multiplying by a fraction, so in this case 3/4, in order to cancel it out, we would need to divide, right? Which is the same thing as multiplying by the reciprocal. So in order to solve this one, I'm going to multiply both sides by 4/3. By doing that, I can create a fraction of 12 over 12, right? Well, 12 over 12 is equal to 1. So those cancel, and we're just left with x is less than or equal to, and there wasn't a negative involved, so my symbol stays the same. And then now let's see here, 12 times 4 is 48 over 3, or instead of worrying about that division, we also could have canceled out, right? Because if I do this and I put that over a 1, well, we can reduce before, right? Or we can simplify, or we can pull out a 3. If I divide the 12 and the 3 by 3, well, 3 divided by 3 is 1. 12 divided by 3 is 4. Now I'm down to 4 over 1 times 4 over 1, which is 16. So x is less than or equal to 16. All right, and then 48 divided by 3 is also 16. So no matter which method you use, either pulling out the 3 or going through with the division, you should get down to 16 either way. All right, final problem of our review. So x divided by -3 plus 2 is greater than 1. So with these, again, we're working backwards from PEMDAS, and so, or the order of operations, so I'm going to get rid of my addition first by subtracting 2 from both sides. That leaves me with x over -3 is greater than, and then 1 minus 2 is -1. Well, now I'm dividing by -3. So again, that little radar needs to be going off in your head of, uh-oh, or not uh-oh, but just, hey, you're going to multiply by a negative, so you got to flip your symbol. So since I'm dividing by -3, in order to cancel it out or to solve, I'm going to multiply both sides by -3. So when you multiply and divide by the same thing, they cancel. I'm left with x, flip my symbol to be less than, and then -1 times -3 is +3. Okay? Oh, and I forgot to graph both of those. I'll graph this one first. Let's see, so we'll put 3 in the middle, 2, 1. Okay, I'm going to circle the 3. That's where my graph starts. I am not going to color in my circle because it's only less than, and then it looks like it's heading to the left, so that's the way my arrow should too. Even with this one over here, x is less than or equal to 16. Well, we got 16 in the middle. I'm going to circle 16, but this time I am going to color it in because it's less than or equal to, so 16 is part of my solution set. And then again, the arrow looks like this side of the number line, so that's where my arrow is going to head. Okay, so I hope this helps you review all of the different concepts that we've been learning in this unit. And of course, as always, if you need extra support, just let me know, okay? Good luck on your tests.